Let us look at another example of loan amortization. The Jackson family is interested in buying a home. The family is applying for a $125,000 30-year loan. Under the terms of the loan, they will receive $125,000 today to help purchase their home. The loan will be fully amortized over the next 30 years. The current rate of interest on the loan is 8%. Interest is compounded monthly and all payments are due at the end of the month. So we have to find out what is the monthly payment that Jackson family needs to make, what portion of the payments made during the first year will go towards interest, and how much could the Jacksons borrow today if they were willing to have a $1,200 monthly installment payment. So here we have been given that the loan amount is $125,000. The total tenure is 30 years. The annual rate of interest is 8% and the interest is being compounded monthly. So what this means is that the period is month. This is because the interest is being compounded monthly. Now let's try to find out the number of periods. So this is equal to the number of years multiplied by periods per year. So number of years is 30 into periods per year. So period is month and number of months per year is 12. So this becomes 360 periods. Now we have to find out the periodic interest rate. So we have been given the nominal interest rate, which is 8%, and we need to find out the periodic rate. So periodic rate is nominal rate divided by the number of compounding periods per year. So nominal rate is 8% and number of compounding periods per year is 12. So this becomes 2 by 3%. I'm not writing this in form of decimal, which is 0.6667, because that will eventually create a lot of rounding errors. So we have established that the period is month, number of periods is 360, and the periodic interest rate is 2 by 3%. Let us draw the time scale. So 0, 1, 2, 3, and so on, and then it will be 359 and then 360. These periods are in months. Rate of interest per period is 2 by 3%. The loan amount is $125,000 and we need to find out what is the monthly installment. So this example actually depicts a real life case, because typically when you take a home loan, the banks require that you make payments on a monthly basis. The loan amount is typically a 20-year or 30-year loan, and in some banks the terminology used for these monthly payments to repay the loan are also known as EMI. This is also the same as monthly payment. It is called equated monthly installment. So let's see how you can find out the monthly payment that you'll have to make if you have taken a loan of $125,000 for a tenure of 30 years at a monthly interest rate of 2 by 3%. Now this forms an ordinary annuity where there are equal payments to be made at regular intervals, and the payments are being made at the end of the period. We know the present value and we want to find out the annuity amount or the monthly installment amount. So the formula for the present value of an ordinary annuity is equal to A into bracket 1 divided by I minus 1 divided by I into 1 plus I to the power n. Now here n is the number of compounding periods, I is the rate of interest per compounding period, and A is the annuity or the monthly payment in this case. So let us plug in the values. So or 125,000 is equal to A into bracket 1 divided by I. So now I is nothing but the rate of interest divided by 100. So this becomes 2 by 3 into 100, which is 2 by 300 or 1 by 150. So this becomes 1 by 150 minus 1 divided by 1 by 150 into 1 plus 1 by 150 to the power n. N is the number of compounding periods, which in our case is 360. So this is 360. So or 125,000 is equal to A. Now 1 divided by 150, so this becomes 150 divided by 1 minus, so here let's take this 150 on top, so we get 150 divided by 1 plus 1 divided by 150 to the power 360. So let me pull my calculator. So we'll first solve this denominator here in the bracket. So 1 divided by 150 plus 1 x to the power y of 360. Now this is 1 by x into 150. This is negative and we have to add 150 to this. So 136.28. So or 125,000 divided by this number, which is 136.28, is equal to A, or A is equal to, so this will take 1 by x multiplied by 125,000. So the answer is $917.21. So this is how you can find out how much will be your monthly installment that you need to pay back to the bank. Now if you are able to calculate this, basically, it becomes very easy for you to decide how much loan amount should you take such that the monthly installment becomes affordable for you. So let me note down the installment on this time scale. Now, each of these installments that are being paid at the end of the months consists of two parts. One is the interest and the other is the principal. So this goes towards the repayment of this amount, whereas this interest represents the interest that we have to pay to the bank. Now each month has a different amount of interest and principal that is being paid to the bank. So now the second part is what portion of the payments made during the first year will go towards interest. So if we take the monthly installment for the first year, how much is the total interest that we have paid, and that interest forms what percent of the installment that we are paying. So let's try to find that. So basically, to find out the interest component in the first year's installments, we'll have to calculate the interest component in each of the month's installment. So basically, we'll have to prepare the loan amortization schedule for the first year. So this is the loan amortization table. We have period, which will be 1, 2, 3, 4 till 12 for the first year. Beginning amount. So beginning amount at the beginning of the period. Payment made during the period, which is nothing but our installments. Interest component, principal component, and the remaining balance. So how much is the remaining principal? So this is 1 minus 4, which is 5. So let's start with the first month. So first month, the beginning amount, of course, is the total amount of loan, which is $125,000. Payment is this much, so 917.21. Interest. So the way to calculate the interest is we'll have to take 2 by 3% of the beginning amount for that period. So basically 2 by 3% of 125,000. So this is 2 by 300 into 125,000. Basically I divided 2 by 3 by 100 because of percentage. These two zeros get cancelled. So this becomes 2500 by 3, which is equal to 833.3. So 833.3. Now, if out of 917.21, 833.3 is interest, then the remaining is the principal. So 917.21 minus 833.3. So this comes out to be 83.87. So we have made a payment of $83.87 as part of the first month's installment. So now the remaining balance will be 125,000 minus 83.87, because this is the only principal amount that we have paid. So this becomes 124,916.12. Now let's take the second period. So now the second period will have beginning amount as the remaining balance at the end of the first period. So beginning amount becomes 124,916.12. The payment or the monthly installment is the same, 917.21. Now interest will be 2 by 3% of this amount here. So this comes out to be 832.77. Now the principal payment as part of the second month's installment will be 917.21 minus 832.77. So this becomes 84.43. And now the remaining balance is the beginning amount minus the principal payment for that month. So this becomes 124831.68. So similarly, let me note down the details for the remaining 10 months. So this is the detail of each month's installment. Now we have to find out what portion of the payments made during the first year. So the total payments made during the first year is all of these, which is 917.21 multiplied by 12 basically. So we have to add all these up. So what portion of the payments made during the first year will go toward interest? So then we have to add all the interest components and find out what portion of the total payment of the first year is the interest component. So the total of all the EMIs for the first year comes out to be 11006.52, and the total of the interest payment for the first year comes out to be 9962.18. So now we have to find out 9962.18 divided by 11006.52 into 100. And this comes out to be 9962.18 into 100 divided by 11006.52. 90.51. So this is equal to 90.51%. So basically, in the first year's EMI or the monthly installment, 90% of the component is interest, and basically only 10%, or actually less than 10%, 9.49% is principal. And also, if you note, the interest component is the highest for the first installment, and then it keeps on reducing, and the principal is the lowest in the first installment, and then it keeps on increasing. Now the Jackson family thinks that they are making a monthly installment payment of $917.21, but they think they could have afforded more. So they say that we can afford $1,200 as payment of monthly installments. So if they had taken a loan where the monthly installments was $1,200 per month, how much would be the loan amount that they could have gotten from the bank? So this is the third part. So let us find this out. So the monthly installment is $1,200. The periodic rate is 2/3%, and we have to find out the loan amount. Also, the tenure of the loan is equal to 30 years. So again, we'll use the formula for present value of an ordinary annuity. So PV is equal to A into 1 divided by I minus 1 divided by I into bracket 1 plus I to the power n. Now let's plug in the values. So PV is to be found out. A is the monthly installment, which is 1,200. 1 divided by I. Now I is 2/3 divided by 100, which is equal to 2/300. This becomes 1/150. So 1 divided by 1/150 minus 1 divided by 1/150 into bracket 1 plus 1/150 to the power n. So this is equal to 1,200 into bracket. This becomes 150 minus. Now let's take this 150 on top. So 150 divided by 1 plus 1 divided by 150 to the power n. N is 360, which is the number of periods. So let me pull my calculator. So let's try to solve this bracket first, and specifically the denominator here. So 1 divided by 150 plus 1 x to the power y 360. This is 1 by x into 150. This becomes negative, and plus 150 into 1200. So this becomes 163,540.2 dollars. So basically, if the Jackson family can afford a monthly installment of $1,200 instead of $917.21, then they can avail a loan of $163,540.2 instead of $125,000.